Hello, in this second video in the series on the algebraic limit theorem, we shall prove that the limit of the sum of two convergent sequences is equal to the sum of the individual limits. Let's look at what that actually means. We basically still measure the distance between 2 points, only the points are represented as sums now. We rearrange the terms such that we have a more familiar representation of them. Those are just the terms we usually have if we want to know if a series an converges towards some limit a. In the next step, we use the triangle inequality and we get those two terms. Because an converges towards a and bn converges towards b, we can find epsilon bigger 0, or let's say epsilon 1 and epsilon 2 bigger 0, such that they are greater than our individual terms. And we can do this because we suppose that our sequences converge. So what we do now is we choose for epsilon 1 this term right here, and for epsilon 2 this term right here, right? We can do this because they can be arbitrarily small, right? If we can choose some epsilon bigger than 0, then we also can choose this same epsilon divided by 2. In the next step, we need to choose the bigger of those capital N's because we have to find an n for which both inequalities are satisfied. Remember, when talking about the convergence of a sequence, every member following the nth member of that sequence must be closer to the limit of the sequence than its predecessor. This basically just states that let's assume n1 is bigger or equal than n2. Then this holds and both sequences or both demands are satisfied. Now we just plug in the numbers and we get epsilon, and because we've just rearranged it and used the triangle inequality, our theorem is proven.